Assalamualaikum warahmatullahi wabarakatuh. Mrs. Juliana Roli. My name is Girindra. I'm from class MR22, here to present my final exam for the uh, uh, subject business analytics. So the title of this final exam is how to maximize profit using linear programming. I'm using the case in a local car wash, actually run by my own family, Nyoman Cuci Mobil Tirtajaya. So Nyoman Cuci Mobil Tirtajaya is situated in Sukmajaya, Depok, West Java. The goal of this analysis is to determine the optimal product mix using linear programming to maximize profit for this business. So Nyoman Cuci Mobil Tirtajaya operates from 8 a.m. until 17 p.m. every day, or about 8 work hours. They have 5 employees, and then they also have 2 hydraulic car lift. It is used to clean the underside of the car, so the car is lifted and washed from underside. And then they also provide interior vacuum cleaning and also a tire polish to the washed cars. Based on my interview, the number of cars on average every day is about 25 cars. So this is to answer section A part 1, which is the first is formulation of linear programming for this particular case, and then the decision variable and objective function, the available resources and constraint, and then linear programming using solver, choosing the right solving method, sensitivity report analysis, and recommendation. The service is provided by Nyoman Cuci Mobil Tirtajaya. They have 3 quite distinct packages that we are going to use in our decision variables. So the first service is a non-hydraulic wash, in which they do not utilize the hydraulic lift. They just wash the car, the exterior body of the car, the regular way. And then the second package is utilizing the hydraulic to exterior wash, but doesn't include the interior detailing or tire polishing. And the third is full service car wash. This one is the complete package. They use the washing the entire body of the car, they vacuum the interior of the cars, and then they also polish the tires of the car. So this is the most expensive option. The pricing for each category for the non-hydraulic is 35,000 rupiah. The hydraulic exterior is the 45,000 rupiah, and the full service is 55,000 rupiah. Based on the interview, we know that the profit margin is ranging from 43% to 55% for each services, ranging from 15,050 rupiah in the most affordable one, and 30,250 rupiah profit in the most expensive one. Because of the increasing complexity of each washing method, the average work time for the non-hydraulic is the fastest in about 20 minutes. The hydraulic one is about 30 minutes. They need to lift and wash the underside and then take down the car, and the full service will take about 40 minutes. From these decision variables, we can formulate the objective function. As such, the profit is the profit of x1 plus the profit of x2 plus the profit of x3. The available resources for this particular business, there are 4 that we can list. There are 5 employees, which they have 8 work hours. But then the detail is that the 5th employee is only dedicated for final checking, cashier, delivery keys to the customer. Therefore, there should only be 4 employees in charge of washing. I will revise this number in the constraint. The hydraulic car lift is only 2 units, so only 2 cars can be washed on a lift simultaneously at a time. But there's also space for 1 car beside the hydraulic. You can see around here, they can be washed without the hydraulic. And then daily soap supply, we count it from weekly supply, which is 60 liters per week, and approximately about 8.56 per day, or daily. And the tire polish, which is only used in the full package, There are 20 liters per week supply, which is approximately 2.86 daily. So the constraint of this particular business in formulation, we already have the decision variables, which is the services provided like non-hydraulic wash, hydraulic exterior wash, and full service car wash. And then we already have the work hour, the availability of the hydraulics, and then the supply of the soap and tire polish. We convert those numbers, like I said, the available work hours down from 40 because we are counting 5 employees, but in reality, only 4 employees are in charge of washing. The other one is for administration, for final checking, and so on. So we revise the number available work hour to 32 hours, and then each average working time for each package, we convert it to a fraction of 1 hour. So like 20 minutes is approximately 0.33, and 30 minutes is 0.5 or half hour. Full service car wash, and 40 minutes is around 0.66. And the hydraulics, which is only used in the second and third variable or package, they have 0 in the first variable, and they have similar numbers used in the work time. I use both in work time and hydraulic, put the numbers average time use, because we also need to count the work time besides the usage of hydraulics in the calculation. If not, the solver, as we tried, it would always count as if the work time of the non-hydraulic wash is the most efficient, and it would always generate the result to the first variable. So, and then the soap used in the first package is quite less, around 0.2 liters, because they only wash the body. And then in the second and third variable, they use more soap because they would use it to clean the underside of the car. And then the tire polish is only used in the full service package, which is 0.1 liter. We utilize linear programming using solver in Microsoft Excel and put those numbers. In this method, we choose simplex linear programming because our objective is an objective function and constraint are both linear. So because those problems involve finding optimal mix of service to maximize profit subject to constraint, with both the objective function and constraint being linear, this method seem the most appropriate. So, and then by using the solver, we get that the maximum profit will be achieved by having 24 units of full service car wash done in a day, plus around 6 units of non-hydraulic wash done in a day. So around 30 car washed by this business, quite similar number to what they have on average, like 25 per day on their records. The max profit provided by this particular product mix is around 830,955 rupiah. So, and this is quite, I think this is quite similar to what they have on daily basis, which we can see next. So with the sensitivity report within the variable, we can see in the above table that in the variable cells, we can see insights how changes in the profit affecting the optimal solution. Like for the first variable, for X1 or non-hydraulic wash, the final value is around 6.49, and they have no reduced costs. This shows that increasing profit of X1 by 1 unit will not change the optimal solution. And the profit per unit can increase by 5,116 rupiah or decreasing by 15,050 rupiah before the change in numbers of units in the optimal solution will be required. And for the second variable or the hydraulic exterior wash, the final value is 0 and have a reduced cost of minus 8,139 rupiah. This implies that the profit of the X2 will need to be increased by at least 8,139 rupiah before it becomes profitable to be included in a solution. So the profit per unit can also be increased indefinitely before it affects the optimal solution. And for the third variable, the full service car wash, the final value is around 24.24 units, and it has no reduced cost like the first one. The profit per unit can increase indefinitely, or it can decrease up to 7,675 rupiah before the optimal solution changes. For the below table or the constraint, it shows how the optimal solution might change if the constraint on the right-hand side values change. For the work time use, when final value is 18.14 hours and the shadow price is 0, in which it shows that the value of objective function will not increase even if there was one more unit of work time available. Because from this calculation, we know that there are quite a lot of work time unused. This can increase indefinitely or decrease by up to 13.86 hours before the optimal solution would change. For the usage of hydraulic lift, the final value is 16 units, and the shadow price is 11.628 rupiah. 16 units here is counting 2 units of hydraulic with each 8 hours of working time or operational time. This means that the profit would increase by 11,628.79 rupiah if one more unit of hydraulic were available. And this can increase by up to 2.85 units or decrease by up to 16 units before the optimal solution changes. And for the soap use, final value is around 8.56 liters and shadow price is 75,250, meaning that the profit would increase by 75,250 rupiah if 1 more liter of soap were available. This can increase by up to 8.40 liters or decrease by approximately 1.3 liters before the optimal solution changes. And lastly, for the tire polish use, final value is around 2.42 liters and the shadow price is 0. This means there would be no change in profit even if more tire polish were available. This can increase indefinitely or decrease by up to 0.44 liters before the optimal solution changes. The recommendations from this analysis is that to maximize profit, Nyoman Cuci Mobil Tirtajaya, this business should focus on providing more full service car wash and also some non-hydraulic wash provided if the demand is available. We know that some people might want faster, almost half the time from doing a full service car wash of 40 minutes to a regular wash 20 minutes. They should also drop the hydraulic exterior wash option to maximize the profit from the 2 packages because from the sulfur they result in 0. Because we see that the car soap is also maxed out in utilization around 8 liters per day. They should also increase the supply of car soap accordingly. We know that it's important to remember that the strategy to increase providing full service car wash and non-hydraulic wash, it still depends on the demand. Assume that the demand is sufficient to sell the projected numbers of unit. And the business should also consider to utilize the remaining work hours around 13.89 hours to further increase profit. And this remaining work hour we will discuss in the next part or part 2 in the project selection. To answer the section A, part 2 in project selection, this is the outline. The first is optimizing a project selection decision, the budget, the project selection and constant formulation, and then we calculate the net present value. We do linear programming and show the result, doing what if analysis, and then giving analysis and recommendation. To optimize a project selection decision from the data, we have real life decision making of Nyoman Cuci Mobil Tirtajaya to expand their business. They have been approached by waxing and detailing another business to join them, and then they also considering to add another hydraulic, even they have one available space, yeah, like the one used to non-hydraulic. They want to add another hydraulic machine or to increase profit, and then they also notice that there are demands that some customers would like if their finished cars if their cars are finished washing to be delivered to their homes. So they don't want to wait at the car wash. So we know that they average 25 cars washed per day, which is translates to 756,250 rupiah profit per day. And then by counting the cost of salary, maintenance, electricity, because their employees are living in the building, they are they came uh, from East Java. They were pencaksilat athletes. So here in Depok, the arrangement made by my family is that they would live in the building, and we provide their accommodation. So the net profit, counting from this cost, is around 132 million yearly. And then the available budget from the projects is around 50% of this net profit, or cannot exceed 66 million rupiah. So the first project, like I mentioned before, is to increase the number of hydraulic by one. The hydraulic itself is around 25,850,000 rupiah. This is quite robust, quite good hydraulic with have H-shaped, and they also charge around 10 million rupiah for the installation, for the creating the excavating the hole for the installation, for the hydraulic, and also for delivery, and then for providing the hydraulic oil to the machine. So in total, this would need to invest 35 million and 850,000 rupiah. This investment is expected to generate additional profit of 11,628 rupiah per day. We get this from the sensitivity report, or about 3 million and 343 per year, or assuming we are doing 290 working days per year. For the second project, there is a proposal from another business. They specialize in car wax and detailing. They want a space on the building. We have unused space. Usually, this is used for a waiting lounge, the outdoor waiting lounge. We also have an indoor waiting lounge. So if the calculations is sufficient, this investment would require around 35 million rupiah to provide the room. This needs a specialized room with well lit, many neon lights, and it is estimated to generate additional profit of 20,000 rupiah per service, with the capacity of providing the service 10 cars per day, or 5,800,000 rupiah per year. For the third project selection, this is from our regular customers. They want us to provide car delivery service. We found that we also have around 13.86 hours work hours unused. So we determined that we need around 10 million rupiah as additional costs to cover the risk of delivering or driving the customer's vehicles, as there have been some minor accidents that we need to cover if the delivered cars are getting things or accidents on the way. So this initiative can generate around 15,000 rupiah per delivery, with the capacity of 20 deliveries per day. And it would translate to 8,700,000 per year. So the constraint formulation first for the budget is that the budget cannot exceed 66 million rupiah. So the formulation is this is from the initial investment 35,850,000 X1 plus 35 million X2 plus 10 million X3 is less than or equal 66 million rupiah. For the work hour constraint, because the additional work hour should not exceed the 13.86 hours. Project 1, we assume requires 2 hours for additional hydraulic. Project 2 requires 3 hours for car waxing and detailing, and Project 3 requires 2 hours for the delivery service. So the formulation is 2x1 plus 3x2 plus 2x3, which is less than or equal 13.86 hours. So we formulate this constraint into a table, the cost, the work hour, and we also determine that the business wants to focus on one core car wash service. So we need to choose between the waxing or delivery. So these can be formulated that x2 plus x3 is less than or equal 1. And to calculate the net present value, we use the discount rate based on the average interest rate for business loans. We use about 12%. So the net present value calculation, to maximize NPV, we use the formula NPV1 times X1 plus NPV2 times X2 plus NPV3 times X3. Where the NPV1, 2, and 3 for each project is calculated using this formula. The estimated profit generated divided by 1 plus the discount rate, which result in the provided numbers. So the results, when we apply these numbers in linear programming, we put the initial cost, we put the projected net benefit, and then we also put the net present value of each project. We need to determine the work hour used if we take that decision, any one or two decision, and then we count the project NPV and the project cost, and then we calculate the total NPV and total cost, which should not exceed 66 million rupiah. So by using the solver, in summary, the recommended projects are Project 1, which is to increase the number of hydraulics by 1, and also Project 3 by providing car delivery service. So by calculation, total NPV from the selected projects would be about 10,776,200 rupiah, and the total cost of implementing those two projects is around 45 million 850,000 rupiah, which is still within the available budget of 66 million. So the project we selected is X1 and X3. And as required, we are doing a what-if analysis in which we try to increase the available budget to 72 million and 600,000 rupiah. But we know that there are two constraining variable in which the first adding around 10% budget will not change the result, because if we want to implement all the projects, we would need 80,850,000 rupiah, or back to the our previous analysis that the business want to focus on one of the service, whether wax or delivery. So this analysis, increasing budget by 10% would not change the calculation result from linear programming. For the second analysis is to decrease the work hour by 2 hours, from 13.86 hours decrease to 11.86 hours. So we want to know if some project might be compromised, especially those that require more work hours, like additional hydraulic would need to be utilized the full 8 hours like the other two. So depending on how the work hours are distributed, the result from this equation solver linear programming analysis, we know that project 1 plus project 3 only require around 10 hours, which is less than 11.86 hours. So even decreasing work hours by 2 hours would not change the result of this calculation. And then for the last what if analysis, if the net benefit from the third project, the delivery one, is increased by 10%, which is from 7.7 million to 9.5 million, would lead to increase in NPV for the project. And this shows that changing the NPV also caused the total NPV to increase to 12,578,343 rupiah. So from all three analysis, we can provide the recommendation. So based on provided software calculation, the recommended projects are project 1, which is increasing hydraulic machine, and project 3, which to deliver cars to the customers. These projects would yield a total NPV of 10 million and 776,200 rupiah, with the total cost of initial implementation or initial investment around 45 million 850,000 rupiah, which is still within the budget of 66 million. And if the budget is increased by 10%, it would not change the result. If we decrease the work hours by 2 hours, it would not change the result. But increasing net profit or net benefit from the third project would increase the total NBV to 12 million and 578,343 rupiah. So we can conclude by doing the what if analysis that the decision to implement both project 1 and project 3 is robust under these scenarios. So this would lead to maximizing NPV within the constraint of budget and also work hours. So our finding can support the strategic direction of Nyoman Cuci Mobil Tirtajaya to focus on their core car wash services while expanding in a way that maximizes financial returns. That's it for the presentation for this final exam. Thank you, Mrs. Juliana. Uh, Wassalamualaikum warahmatullahi wabarakatuh.